So in the 14.2 extension, we are still determining if x and y are in a proportional relationship. We did that in 14.2 when we wrote ratios and then just reduced them to see if those ratios were equal. But now we're going to use a graph. So just by looking at a graph, we can tell if the relationship is proportional or not. Sometimes though, we're going to be asked to draw it. So let's take a look at the first set of XY coordinates. I'm going to set them up this way so it makes a nice fraction for us. So 2, 6, 4, 8, and 6, 10. Okay, so we're going to set up our XY axis. Okay, so we're going to set up our points. We have to count by equal intervals, 2, 4, 6, 8, 10. Okay, I'm going to count by twos. Looks like for the y-axis, counting by twos is also appropriate. 2, 4, 6, 8, 10. And then our numbers here turn into our ordered pairs. So the first ordered pair that we need to plot is 2, 6. So x is 2, y is 6. Plot that. Our second ordered pair is 4, 8. Okay, so 4 is x, 8 is y. And our third ordered pair is 6, 10. Okay, so 6, 10. Now, when you plot these points, they usually will only give you, 3 or 4 points to plot. When you connect them, you want to connect them in a straight line, okay? Remember, you're going to have a little human error, so it's not going to be perfectly straight. Don't mind me using my table mat instead of a ruler. Okay, and then we'll add an arrow to extend it in that direction. Before we talk about if it's proportional, we're going to do a second one and then we can compare. Okay, so for the second example, we're going to have an example of one that isn't and one that is proportional. I bet you can already tell by looking at these ratios if they are proportional or not. So x and y. We'll do 3 pairs here, 1 to 2, 2 to 4, and 3 to 6. Now again, I bet if you look just at the ratios, you already know if it's proportional or not. But unfortunately, you're asked to graph, so get it done. Here we go. X, Y. Okay, and I'm gonna just count by, ones along the x-axis because I only need to go up to 3. 1, 2, 3. And along the y-axis, I could count by ones, I guess, or I can count by twos. I'm just gonna count by twos. 2, 4, 6. Okay, and then we will plot these ordered pairs. So the first ordered pair is 1, 2, and then 1, 2. Second ordered pair is 2, 4. Third ordered pair is 3, 6. Again, you want to connect. You're gonna have a little human error like I do. Second point's a little high. Okay, so here are 2 examples of graphs, one that illustrates a proportional relationship and one that does not. Okay, so again, based off the ratios, I bet you can tell. Okay, this is our proportional relationship. 1 to 2, 2 to 4, 3 to 6, those are all equivalent, they'll reduce to 1/2. Looking at the graph, this is the big idea right here, okay? This is proportional because the graph passes through the origin, through 0, 0. And that would be the explanation that you need to write. So this is proportional, or you can be even more eloquent and say X and Y are in a proportional relationship because, so proportional relationship, ooh, that was sloppy, because graph passes through origin. Remember, the origin is just the fancy name for 0, 0. Okay, and then we would use the same reasoning here for why this is not proportional. When I extend this graph, the y-intercept, in other words, it hits this y-axis at 4 and it doesn't pass through 0, 0. So that's how we can tell just by looking at it that this is not proportional. So x and y are not in a proportional relationship because the graph, we're using the graph as our evidence, does not pass through, well, I'm messy today, the origin. In other words, it does not travel through 0, 0. Okay, that's the main idea of today's lesson, the extension, but there's one more thing that I want to review with you. You're going to be asked to, before you determine if it's proportional, you're going to be asked to interpret each plotted point. So let's just make something up, like 1, 2, 3, 4, this is X. We'll call this, I don't know, hours worked. And here's our y-axis. We'll call this dollars earned. Okay. And I'm going to count by 20s, 20, 40, 60, 80. And I'm going to make it proportional. So I'm going to start at 0, 0. 1, 20. I guess I could label this 0, 0. And let's say 3 and 60 is another point we're given. Okay, and we'll just do 3 points and we'll connect them like so. Okay, and then I don't know, maybe you need a title because I've always taken off points for no title. Money earned. I don't know what your job is, but money earned. Okay, so if we want to interpret each plotted point, all you need to do is say what that plotted point represents. So if we take the first one that was identified, 0, 0, that would mean $0 is earned for working 0 hours. Duh. That one's kind of funny. Okay, and then we take another plotted point that's given. Forgot the close parenthesis. 1, 20. That would be, let's see, 20 represents dollars. So $20 is earned for working 1 hour. And I think you'll get the idea. You could probably do that third point on your own. And then again, to review, this would be a proportional relationship because, why? I'm waiting. What does the graph do? Are you answering me? Because the graph passes through the origin. Okay, try out those practice problems.